And I am Tomoya Matsuura from Tokyo University of the Arts. And I'd like to start my presentation co-authored with Kazuhiro from Kyushu University and Akihiro Kubota from Tama Art University. And title was a little change from the one in the program, the civil engineering of music, a media archaeological approach in the development of mimium, the programming language for music. And this presentation is my excerpt from my PhD thesis that I submitted last March, and more focusing on the historical aspect. And before starting my presentation, if you have a question about my presentation, it will be really helpful if you can post it to a chat thread if I ask. It is okay to send only from me, or of course send to everyone. Thank you. So the main theme of this presentation today is rethinking the history of technology-based music through making. And this sentence contains two contrasting aspects. Now, one is giving a perspective of the person who makes something, developing the programming language to the field of historical research. And at the same time, it may be useful for the person who does a kind of a practice-based research to contextualize their research by revisiting the history, simply taking historical research into the process of making. And the starting point of our research was the development of the programming language for music mimium. And this is named short of minimal musical medium. So before talking about the main theme, let me introduce this language and its development briefly. Mimium is a text-based programming language that can generate audio signal, like as a famous environment such as C-Sound, Supercollider, Faust, and so others. This is a simple example of the usage of mimium language. And you can define basic signal processors if like their usual function in general purpose language, like this phasor function, which is unipolar sawtooth wave in a range between 0 to 1, like the figure in the left bottom. And one of the unique points of this language is its implementation. Mimium is implemented by adding a minimal set of features for music, or more simply temporal control, to the design of a general purpose functional language. The minimal feature here, I mean, is abstraction of the hardware and logical time-based event scheduler and functional representation of signal processing, like this example. So for example, the special keyword self, like in this phasor function, can be used to get the result of the function itself in a previous sample. So in this example, the small amount of value is added to the previous result of computation constantly. And if the result exceeds 1, it goes back to 0 and start increasing again. And this means the use of the self keyword is equivalent to the expression of the recursive connection of the signal processor in the usual node-based environment like Max. And this is a comparison between several existing languages. And Mimium has several advantages that it can handle deterministic and sample accurate event scheduling like the other modern language such as Chuck. And user can also define a unit generator such as filter oscillator from the very primitive level, while conventional language with user to use many kind of built-in black box generator, usually written as a general purpose language such as C or C++. And this figure illustrates the structure of Mimium's execution environment, in other words, the compiler and runtime programs. And the compiler part from the left has a structure almost same as the general purpose functional language, for example, IRCAM, except for the part of the analysis of the internal state variables for signal processing. This is used for the special keyword self, as I told before. And as you can see, this running environment does not contain any elements that are directly related to music, like 12-node processing or the MIDI processing or the rhythm pattern processing. And in the first place, Mimium was intended to be mostly domain-specific language that is specialized for music, but not embed any specific musical style to its language specification. Therefore, the disappearance of the musical task from the implementation of the language itself is, in a sense, it's no surprise. But still, it was kind of a surprising thing for me because there was 1 or 2 years, 80 or more than 99% of the knowledge needed to implement this language was not related to music, but theory of the programming language, like what is a closure and how to translate it into imperative form, what is a single static assignment format that is used to intermediate format of the language. Anyway, but realizing the how to simply new musical style is one of the common purpose of any type of tool for music or other creativity support tools, including programming language as well. However, in the case of programming language, there is some kind of contradictory situation that the more general the language becomes, not to be restricted by existing musical styles, the less musical topics seen in the development process of the language itself. So one of the questions come to me through the development of the language was how the people who develop or manages the infrastructure around music keeps motivation or maintain the project or imagine the future of the culture they are going to support without the actual practice related to music in their development. So recently, several media studies have examined the effect of infrastructure, such as format or protocol, on musical culture. For example, Jonathan Stan's cultural narratives of the MP3 format. However, there seems to be no studies that can provide guidance on how should we actually make a better infrastructure. And therefore, we also encounter the difficulty to take a claim of novelty of our research when we propose mimium as an engineering research. And this is part of the review comment when I submitted the first paper about mimium to kind of engineering-oriented conference. And certainly mimium was not instantly useful tool at the time. And even now the situation is not so different because it still have no standard library or integrated editor with graphics. That program is just a command line tool. But then the question is, should researchers who make tool or infrastructure for music always only deal with mixing or practicing program for musicians? So is there no other ways to research neither the problem solving nor just exploring a new expression? That is what we want to talk today. And what we attempted this time, maybe this kind of analyzing cultures through the experience of tool making, especially focused on the approach that revisiting the history of media and the infrastructure through the experience of engineering. And so basically the history of the computer music started from the very beginning of the history of the computer itself. And the history of the programming language for music is a similar situation. Today, the programming language for music feels like an applied system of the general purpose language to music, but the music series, the ancestor of today's programming language for music, and that is usually sold as the first computer music system, was developed in 1957. And it was mostly the same time as the Fortran was developed. This is the first general purpose programming language. And in this time, still the notion of the programming or programming language itself were still not have been concretized compared to today's situation. And moreover, there were many attempts before music series to generate sound on computers. And in the early computer, because the operating frequency, the main CPU clock, was in a range of the human limit of hearing senses under 20,000 hertz. So there was a common way of debugging that connect an amplifier and speaker to listen to the operating binary logic signal directly. And media researcher Miyazaki called this activity as algorithmic listening. So engineers then naturally started to assemble program to control the frequency of the signal that is connected to speaker. Then they could play some melodies of famous pieces. Of course, the sound was just a beep sound because it is one bit binary logic signal. So therefore, Hari Tanaka, the researcher of the history of chiptune, situated this activity as one of the ancestors of today's chiptune culture. And so most of their attempts in the early computer are just reproduction of the existing song's melody. However, in the case of Pilot Ace in UK, the engineer have found some interesting sound that comes from the specific operation of the acoustic delay memory. Acoustic delay memory is the major memory apparatus at this time. And though we could not listen to the sound or what the sound was actually like because there was no recorded sound, but anyway. And more, in the first place, our computers themselves was structured on the pile of sound engineering techniques. Acoustic delay memory I mentioned that is usually in Pilot Ace. Now, this is one of the earliest memory apparatus storing data as saturated acoustic pulses that uses the metal tank filled with mercury and attaching the speaker and microphone at the end of the tank and saturating the acoustic pulse as the binary data. And John Pressback, who developed this apparatus, and he is also known as an inventor of the one of the inventors of the first computer ENIAC. And he, according to the life interview, he grew up as a kind of sound engineering hobbyist, and led him to use his experience. This experience led him to use acoustic technique to create this kind of the structure of the earliest computer that uses acoustic technique. So maybe we can think making electronic computer itself can be thought as one of the form of participation to the music and sound culture. So usually the origin of the computer music is thought as music series and Max Maschus, but there are subtle gradation between the early attempts to generate sound using computer, like Pilot Ace music utilizing acoustic memory and algorithmic listening activities for debugging and maybe invention of the acoustic memory itself. So why Max Maschus is thought as a kind of origin of the computer music so much? And actually, Max Maschus himself was taking himself as a scientist, not a musician. And so maybe he is thought as not so different from engineers who was playing around the computer in the early 50s. So his initial motivation to develop computer music systems seems like coming from his failure to improve on a traditional instruments like violin. So usually there are two types of instrument in band. One is the person who wants to make an instrument that can play like professional music without much effort. It means that they follow an existing musical value. And another is the person who build an instrument to go beyond their current musical value. And for me, Maschus was much right. Seems like the person who wants to deconstruct musical value, including his later works like Radio Button. But certainly music series was remarkable in the sense of that system was the first attempt to build a kind of user-friendly or musician-friendly system, which means musicians did not need to know the deep inside of the working principle of the computer itself. Musicians do not need to be an engineer of the computer. In other words, Maschus can be seen as the first root of the history that began with the people just using computer make sound, to branching out into the musician and scientist. So this division of the role between scientist and musician became deepened through the history and existing today's computer music ecosystems. So Max, one of the most famous computer music systems today, and the name comes from Maschus, represents its situation well. There's Max system. There's some user of the Max that connecting many built-in black box objects. The composer makes Max and PD patches. And some people develop the object itself. Sometimes this is called external object by writing C or C language. And there are also people who develop Max itself. And Mira Packet, who is the original developer of the Max, said that this layer system of Max purely directly came from the division of the labor in IRCAM, one of the most computer music research institute, and where the Mira Packet developed the Max. And in the IRCAM, there are composers who make pieces and researchers who build the fundamental systems. And in between, there was a realizer, which have been called musical assistant before. And Max, it was originally developed for the control system for the workstation called CrackleX. In the 1980s, you can focus on developing kind of extremely basic technology like this workstation that can operate in real time with the variable, the capability of the signal processing. And musicians were not involved in the development process of this CrackleX. The CrackleX is usually seen as a kind of remarkable result from the view of the serious computer music history, since this is a product from the collaboration between engineer and specialized engineer and musician, and it realized a novel electronic music. For example, this is notable that is used for making Weapon by the piece by Pierre Boulez, the director of the IRCAM at the time. However, at the same time, CrackleX is strongly criticized because the technology developed at a National Research Institute for Computer Music finally produced an apparatus for military purposes. The CrackleX was initially going to be commercialized for, of course, for computer music purpose. However, because its complexity of the system, it failed to complete commercialization, except for the acoustic simulation. I think this was for the submarine sonar for military research. And this was the primary business of the Sojitech company who did a hardware production of the CrackleX system. So here we can see kind of interesting contrast between early computers' experiments in sound and 1980s IRCAM situation. Certainly, ENIAC was used for calculation of trajectory of bullets. Several parts of the core technology in the early computer came from kind of a hobbyist sound engineering technique. And IRCAM was indeed an institution for the computer music, but it developed a machine for computer music, but it was eventually put to military use as well. And so there may be a number of the possible considerations for the contrast. However, for me, the important fact for me this time is that the division of labor, according to expertise like musician and realizer and engineer, does not always lead to the good result for each of the field. So let's go back to this comparison table. So our practice of designing mimium can be thought as an activity to deconstruct the division between musicians and scientists by implementing the fundamental part of the abstraction of the sound in a computer with a bottom-up manner by adding the minimum feature on the design of the general purpose language, not separating the target domain of the language, such as only for DSP or only for MIDI and only for rhythm pattern processing. So whether it worked or not, as a result, the development of mimium was thought as a pursuit of a certain generality by taking a bottom-up design. And this figure is a kind of metaphorical expression adapting from the score orchestra instrument division in C sound. And under the layers, there are maybe who develops the instrument using C++ and who develops the C++ and who develops the computer architecture or blah, blah. And one mimium hub tribe can be thought as filling the gap between these steps. However, what I want to insist here is not like the statement like we should pursue more generality for the programming language for music, because one big takeaway from the development of mimium was pursuing generality makes another division of the label. That means library development on the language and the development of the host language itself. So like the knowledge needed to develop mimium was mostly same as the knowledge to design of the general purpose language. So it was really difficult to invite the contributor of this mimium development project because the ordinary language designer do not know the motivation to implement language for music. And 99% of the language designer don't know that there is a famous software called Max, like that. And but the programming language they was really, really sophisticated and hard to catch up its knowledge. And how should we make type safety or multitasking or blah, blah. This cannot be avoided by principle because there are always the designer of the tools and the user of the tools. But the hard division is a kind of result of the history of expertisement by computer scientists and maybe computer music practitioners. The way to change the situation of the divided role was not a universal language, but maybe the change of the culture itself. So over the time, as technology stack become more and more piled it seems to be only the upper layer of them applied to another field, music. And this seems to be only one form of the relationship between technology and music, at least from the engineering side. For example, today, the artificial intelligence or virtual reality and like that. But still lower layer of the technology significantly makes the effect on our musical culture. For example, streaming services like Spotify changed our daily style of listening to the music significantly. But how such an infrastructure made by who and for what and by how was not really known. And it was only be analyzed later on the infrastructure have been built. So at least there seems to be no academic research field to make or build such an infrastructure with a 10 or even 100-year perspective. So we are trying to call such an academic field as civil engineering of music that explores an alternative form of technology that may not directly made for music, but may cause an effect to music, including programming language. The equivalent word of the civil engineering in Japanese is called Doboku Kogaku, and this is one of the reasons that I named this field as civil engineering music. And this literally means the soil and wood of the engineering of soil and wood. And that simply represents engineering for an infrastructure. Then, of course, the word civil engineering implies that engineering is done by citizens, because originally this word is made to clarify its standpoint from military technology that was previously main field of engineering. This naming is kind of a camouflage because it likes as if it is a sophisticated academic engineering subject. So that the totally scientific field may be seen as an interesting academic field. But the core of the civil engineering for music is, of course, as I talked today, are the deconstruction of the existing expertisement division labor. So at the moment, the development of mimium is on a break. But so for now, I'm doing kind of subtle maintenance and exploring a way to continue to develop mimium, at least as an interesting tool to use, whether it is really useful for current music production or not. Because anyway, I learned that there's no silver bullet or universal language. So then at least I should make my tool something playful so that some people can start using unexpectedly, like in the early computers experiments. In addition to that, I hope to create, even if slowly, a place and community where we can continue to think about this kind of idea for that may seems to be modest or unnoticeable, but may have a significant impact in the future of music. So thank you so much.